Okay, welcome back. Today we're going to start talking about some really cool stuff, and I'm going to introduce the complex plane, or reintroduce the complex plane to you. Complex numbers have been around since about the 1600s. I think it's late 1500s. And so you'll remember first this notation. I is the square root of -1. And this is not a real number, and just in case you haven't seen these arguments. Why? Okay, so first off, what motivated this? If you're trying to solve this, x squared minus 1 equals 0, you do this. You factor this out. This is x minus 1 times x plus 1 is equal to 0. That means either this, x minus 1 equals 0, or x plus 1 equals 0. So we have x is 1 or -1. So what about if we're trying to find a solution to this? X squared plus 1 equals 0. Well, this is problematic, and the reason is, of course, in real numbers, here's a graph. Here is a basic picture of y equals x squared plus 1. There's no intercept. This has no solutions because it doesn't touch the x-axis anywhere. However, there are many practical mathematics problems that require some kind of solution to this. Really, this is called factoring. The big deal about this, what we did here is we factored this. These are equivalent of prime numbers. 21 is 3 times 7. Here is the prime decomposition of the number. Well, for polynomial functions, which all look like this one way or another, an x to the n plus an minus 1 x to the n minus 1 plus ... plus a1 x1. I have to get rid of this here for a second. Y equals x squared plus 1 plus a0. All polynomials have this general form, and it turns out that back in the day, in particular, these were the most useful functions people could figure out for modeling things, and they have many nice properties. However, it's also very important to be able to factor them into what would be prime elements, okay? And in the real number field, x squared plus 1 doesn't factor. So around 1600, it was a little before that, somebody whose name escapes me for the moment, came up with this notion of how about, and they didn't label it I, this came later, but let's talk about the negative square root of 1, right, as a solution, because this, x squared plus 1 equals 0, this is a solution. Either I is a solution to it, or negative I. And the reason's obvious. If you're squaring a square root, the square root goes away. So this will be minus 1 plus 1. Doesn't matter if it's minus I because the square will kill off the minus. So that's all well and good, but here's the problem. What number squared is negative? So this says basically I squared is -1. This is problematic because if you have a real number squared, so is I a positive number? So this is a good question, and I'll use this tricky notation. Is I positive? My board works all over today, so we're having one of those days. Well, is a positive real number? What happens to a positive real number? If you multiply two positive real numbers, so if a is positive, a times a is definitely positive. Also, but this is I squared is negative, so it can't be a positive real number. Is I negative? Well, if a is negative, a times a is positive. And remember why that is. If you have an even number of minus signs, they're going to cancel each other out. And these are not great looking a's. Let me make them a little cleaner. For example, -2 times -2 is equal to 4. We know that. So it's not a negative real number. The bottom line is the negative square root of 1 is not a real number. And here is a big, big deal. They call this, the reason why the I is here is this is the imaginary part. However, this is very misleading because there are no real numbers anyway. You will not go out and find the number 1 if you go looking for it. It doesn't exist. These are all mental constructs. So when we talk about imaginary numbers, people think that somehow they have less credence than real numbers, and this is not true. As a matter of fact, most physics is done in the complex plane. But anyway, we'll talk a lot more about that. This stuff is just really neat. If you're into science, if you're into physics, this stuff is neat. Okay, so let's give you some of the basics. And I'm assuming that absolutely everybody watching this has had complex numbers before. In theory, it's supposed to be covered in your algebra class. So complex numbers have this form. They look like this, A plus IB, okay? This is the real part, it's called the real part, and this is the imaginary part. So right away, let me start saying that this is also a complex number, A plus BI. I've actually seen instructors be very specific about which way that you write these, but here's the deal. Complex numbers are written like this, and we'll give you an example. 4 plus 5i. Incidentally, this is a complex number. Where would we map it in the complex plane? Well, the complex plane looks like this. Here's the x-axis. This is called the y-I-axis. So, I got 5i, so 1, 2, 3, 4, 5, 2, 3, 4. It works just like the coordinate plane that you're used to using. First, we look at this, the real part, which is 4, and we go to 4. And then we go up 5i, which is 1, 2, 3, 4, 5. Okay, so that's where 4 plus 5i is in the complex plane. You'll notice that this is the preferred notation in general, A plus IB. There's one case when it isn't, and that is if B is a radical. Generally speaking, you don't want 2 plus the square root of 7i. And here's why. It's not easy to tell. If you're writing by hand, the I ends up looking like it belongs in the radical, just depending on how well you draw or how well you write. This is the way that it is preferred. 2 plus the square root of I, or 2 plus I times the square root of 7. If B is a radical, it's typical to bring the I up front here. Believe it or not, though, there are some instructors who feel that this is the only correct way to write this, and they will charge you points. So just make sure you know your instructor and what they really want. I think that this is much easier to read 2 plus I times the square root of 5 as opposed to 2 plus the square root of 5i, where the I may look like it belongs in there. Okay, so we got a lot of interesting stuff coming up today for a change. I'll see you in a minute.